Welcome back. We want to classify these 5 triangles with as much information as possible. So let's take a look at the first one. This first triangle, we have 3 sides that are 3 different lengths. Anytime we have a triangle with 3 different lengths for the sides, we have a scalene triangle. But we don't want to stop there. We can look at the angles as well and get some more information out of this. We can tell that all 3 angles are less than 90 degrees, which is called an acute angle. So we can label this triangle as an acute scalene triangle. We want to be as accurate as possible, and we want to label it with as much information as possible. So we don't want to just call it an acute triangle or just a scalene triangle when we can call it an acute scalene triangle. Really gives us a better idea of what we're working with. All right, let's take a look at this one. Here we have a triangle that, again, has 3 acute angles, but we also have 3 congruent sides. Anytime we have a triangle with 3 congruent sides, we have what's called an equilateral triangle. An equilateral triangle, by definition, is also an acute triangle because all 3 angles are going to be the same, and they're all 3 must be acute. So we can just write this as an equilateral triangle. All right, let's take a look at this one. Here we have 3 different sets of dash marks. This means we don't know the lengths of these sides, but we know that all 3 are different lengths. So this is a scalene triangle, but we also want to, when we're looking at the angles, we want to be careful because we don't want to assume that this is a 90-degree angle, even though it may look like it. If we don't have the box in the corner, that means that we can't just assume that that's a right angle. So we must say that this is an acute scalene triangle. We can't assume anything in geometry. That's why we have such comprehensive and extensive notation. So we want to be accurate as possible. We know that, if anything, this is less than 90 degrees, so it's an acute scalene triangle. All right. This one, we have a box in the corner, so we can go ahead and say that this is a right angle. So this is going to be a right triangle, but we also have these 2 sets of dash marks. That means that this side is congruent to this side. Anytime we have a triangle with at least 2 congruent sides, this is called an isosceles triangle. Okay, so we have a right isosceles triangle. A right isosceles. One more interesting note, if we said that if we have a triangle with at least 2 congruent sides, we have an isosceles. And up here we saw that we have a triangle with 3 congruent sides. This is an equilateral triangle. That means that all equilateral triangles are also isosceles triangles. Very, very cool. And let's take a look at the last one. Here we have a triangle with 3 different lengths for the sides, so we know that this is a scalene triangle. And we also have an angle that's greater than 90 degrees, called an obtuse angle. So this triangle is an obtuse scalene triangle. All right, very straightforward. Let's take a look at the next one. Here we're asked to sketch an equiangular triangle. So what is an equiangular triangle? An equiangular triangle is a triangle with 3 congruent angles. And it's going to look very similar to an equilateral triangle because for all 3 angles to be congruent, all 3 sides also must be congruent. So that means that it's going to look identical to the triangle above that's an equilateral. We just need to label it as such. So an equiangular triangle, we know it as such if all 3 angles have the same measure. So we're going to put a ring at all 3 angles, and that makes this an equiangular triangle. Oh, excuse me. An equiangular triangle. We can also further label this because anytime we have 3 congruent angles, we know that the sides are also congruent. And these are things we'll actually prove in a later section. Very, 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 very interesting. And let's take a look at the last one. The last one we're asked to sketch an obtuse isosceles triangle. An obtuse isosceles triangle, well, we saw an isosceles here and an obtuse here, so we know 2 things. The triangle must have one angle that is greater than 90 degrees, and for it to be obtuse, and for it to be isosceles, it has to have at least 2 congruent sides. It can't have 3 congruent sides because for it to be an obtuse angle, it has to have an obtuse triangle. It can't have 3 acute angles. So we know that an equilateral triangle has 3 acute angles, so it only has to have, we need a triangle with 1 obtuse angle and 2 congruent sides. So let's go ahead and see if we can draw this. So here's one side. And let's go ahead and make this our obtuse angle and our 2 congruent sides. And we can join it like this. Let me draw that a little better. Make sure that this end is closed. Okay, so let's go ahead and label this. We can easily assume that this is actually an obtuse angle, but if we want to be more thorough, we can go ahead and call this maybe 130 degrees or such. We just want to make sure that there's no ambiguity that this is an obtuse angle, and we want to label this. We can either write some lengths right here, or just put 2 dashes here to clarify that these 2 are congruent sides. So here's this is our obtuse isosceles. All right, so we're classifying triangles, and we're using notation, using what we've already learned to actually identify the triangles and actually sketch a few triangles. So not a whole lot to it. And the next section will actually be classifying some polygons. We'll actually be looking at some different shapes other than triangles. So look over this a few times. Make sure we get a good handle on this, because we will need this. We will need to know this very thoroughly to go throughout the rest of geometry. So I'll see you in the next video.